So, we've already seen how we can make a lightweight finite state machine. Now, let's do something similar, but this time we're going to use Unity's component system so that we can actually, make it a little bit more plug and play. Okay, both systems are, they are useful for what you want to do. It depends on what you want to achieve and stuff like that. Okay, so there's no better or worse. It only depends on the occasion. Okay, so we have an empty project and we can have, I've already made a folder called scripts. So let's go start creating our scripts. So I'm going to make a new script, which again is going to be the state manager, because the state manager is basically what's going to control which state we're in. I'm also going to, in this sense, state manager is basically our data container. Okay, it's going to hold some data that's relevant to our own player, or it's relevant to anything else that we want to have. Then I'm going to create a state again, and of course we can create state actions, or we can just keep them as state. This will be the base class for anything else. So let's not worry about state actions. Okay, so we're going to keep it as state manager and state for this occasion. I'm going to open up my state manager, and I also would like to open up my state. Let's open them from here. Let's open the state. Now, I'm going to add a namespace, but it's going to be under component state machine and not under just my regular namespace. Okay, and now I'm going to delete, start, and update as well. I don't want this to be used, even though I'm still going to keep it as a mono behavior, because we would like to use it as a component. Then I'm going to keep it as an abstract class, which means I can't actually drag and drop this class as it is. I will have to implement a child class that derives from this state. Okay, so let's save and let's add on our state manager. Let's add the namespace first of all. And let's delete this for now, and we're going to handle them later. Then the first thing we know is going to happen. We will need a state, which is going to be our current state. Okay, then let's keep start, and maybe let's keep update as well. Inside our state, we're going to have a method for basically running the update for the state. Because this is an abstract class, it means we wouldn't really be able to implement a body, and well, we could, but we would like to, each child class, we would like it to create its own body. So we could either add this as an abstract void, and pretty much, keeping it as an abstract void will just do the trick. We can also just pass the time, pass the delta, which we can be passing from the state manager. So our update can look something like this. If current state is not null, then current state dot tick and just pass the time dot delta time. I'm usually using the tick or passing the time dot delta time just to save a little bit of performance, because calling dot delta time, it creates some it's not really that much of an important call, but it's some slight optimization. So, okay, we have our current state and we have all of these, but we need a way to know that this state now needs to be active on the state manager. So how should this be handled? We're going to create a method for basically keeping this as conditions. Okay, in our case, we can basically just use delegates for this. So we can do a delegate void condition checks. Actually, maybe delegates are not really the way to do this, because we would like to add it and remove them. So let's not use a delegate, let's just use a classic list, because why not? Okay, which is going to take a state, and we can just do all states here. Let's do it like this, and then we can run a method, an abstract method in this case as well, public abstract void condition. And for condition you can also pass the delta, and you can also pass the data container, though I would like to keep the data container clear of the conditions, or clear of the abstract methods, because we could just implement them inside our component and it should be done. So okay, then on update, each one is going to be running its own state or its own tick, and in theory we wouldn't even need to run actually the all states. Yeah, okay, let's not use conditions for now. Let's try to keep it like this. Let's delete this so we don't get confused. Okay, so this now it's going to be running some state. Let's use a data container now, and it's going to be a simple test data container. Okay, I don't necessarily care what else is going to be using, and it can be a mono behavior, but it can also just be a class. Okay, just use your imagination on this. All we're going to do is get some input. So I'm going to do horizontal, classical, and then I'm going to do vertical. Okay, so we have our two inputs. Let's add some, maybe space, so we can add maybe a key or not. So we have horizontal and vertical and space. Then we can go and implement a new state. But actually, yeah, okay, let's go and do this first as a state, and then we'll worry about the rest. I'm going to say test input state. Okay, and let's delete all of this. And this is now going to derive from state. Because state is an abstract class and it has some abstract methods, in this case it's the tick, we will have to actually implement the method for the tick. So here's the trick. Because this now is a component, we can basically just either use the classical thing, test data container, my DC, and just drag and drop it in the inspector. Okay, we can either do that, or we could just, and we can do the same one for the state manager as well. Okay, we can do this, or a better solution to this will be on enable DC, get component in parent, or get component, we don't really care, test data container, and states, get component in parent, test data container. Yeah, state manager. Okay, but because on enable it's going to be running all the time, if we do this on start, it will just be better. So we have the get component in parent. Okay, so we are populating our values. If we keep the data container separate from the state manager, it means we can reuse the state manager for different cases where the data container can be a variable. It could change, it can be something else. So for example, an enemy might not have the need for the data container the actual player is using. So, okay, just keep that in mind that the state manager might not even have a need. You might have a need for this if you are actually would like to, change a state from inside this state. Which means we can just go and say, let's get some inputs. So horizontal equals input get axis horizontal. Okay, then of course vertical, we'll just get the vertical axis. So this will now be populating the data container we have over here. We can run this. The setup for this is it's going to be super minimal. It's not really need anything. It doesn't really need anything. We just add a state manager, okay, and then we can just add the test input state, and of course we also need the data container. Once I hit play, you will see that the test input state is going to populate both the data container and the state manager. Now these don't actually need to be public. Keep that in mind because there's actually no need. We know that they populate. But here's the thing. If I press any inputs now, nothing's going to happen. But the cool cats among you will notice that the current state is actually empty. So it doesn't actually run anything. It doesn't actually run the tick for the test input state. If we drag and drop this here, and now I'm starting to press keys, you can see that they go and update and so on and so on. Okay, awesome. That's what we need. We can also drag and drop it from again. And let's go here. We can remove the public and just keep it private. But let's say we now want to create a new state. Let's create this new script. And let's say we want to create a new state that's going to be the test. Okay, test string state. I'm going to add it under the namespace. Okay, implement the abstract class. And for now, let's just do a variable, public float, timer max, float, timer, let's say every 2 seconds, and then timer delta if timer is higher than the timer max, then timer should be set to 0, and just write debug.log string state. Okay, and this will be our new state. Then on the test input state, I would like to make it so if input, or better yet we can say dc.space equals input dot, let's do get key down, in this case key code dot space. So if you're pressing space, then you can check for dc.space. Obviously we could just do as well, we could do this, but I want you to get into the habit of having the data container and updating it from a different script. This is just an example, so I don't really care how this is going to turn out. Keep that in mind. Okay, so if dc.space, then we would like to use, or we would like to change the component on the state, the current state. But here's the question we have in mind. How do we know on which state we actually want to go now? Really simple. You're just going to do a public state, and I'm just going to give it a name as string state. I could just do as well test string state, and I could only add a component or a state class that is also a child that is a test string state. Okay, if you want to keep it agnostic, so you don't know yet what state you want to go in, then you can just keep this as a state. So, okay, then current state equals string state. Let's copy this and let's go onto the test string state. Let's paste this, and right now I'm just going to be lazy and just copy this, paste this in here, delete that, and then as you can see we do need a reference to the state manager. So on start we can have the state manager here, get component, state manager, and so on. And now we need to go back onto that state. So we can do public state input state. Okay. Now let's say on the test input state we're going to run a debug log on every frame, doesn't matter, and we're going to be saying input state. Okay. Minimize that and let's try it out. Of course, we will need to have actually I would like to put the data container on the top. So my idea is data on the top, state manager which handles which state you are in below, and every other state is below. These don't actually need to be on the same game object. This could just be on child objects, since we are using get component in parent, whichever is used to better. So let's drag and drop the string state. Okay, we need to know which state we're going in and which state we're going up there. We're going to polish this in a bit. Let's see this, how it works for now. So you can see that I am in the input state. I can update my data container from my keys, and once I click space, which is this, we're now going into the string state, which updates every 2 seconds and so forth. If I click space again, then it moves back to input state. So let's start polishing, because drag and dropping, it's not really that ideal either, is it? So it's a little bit more, you can make sure that everything is in the right place, but you can get lost really easy from drag and dropping. So I do know that from my string state, in theory, I know that I'm always going to be going back onto the input state, or we can just do a default state here. So for example, public state, default state, and we can have a method for going on to the default state. So we can say public void reset or back to start state or default state. And of course, current state will be just your default state. Okay, this is a fast way to revert the state manager to whatever case it was before. Obviously, we can create a method for change state and passing the state over here, or target state. And if current state is not null, then current state dot exit, so on, if you want to run any logic on that. Current state, then target state, and of course you can also do current state is not null. On enter and run any logic you want to run over there. Okay, we're going to see this more in depth in an actual series before we, encumber you with a lot of info that we're not going to use right now. So just keep that in mind, that there is a lot of things we can do. So you can just say change state to default state here, and it will run the same logic as everything else. And if you don't want this to be public, you can just make them serialized fields, so you won't be able to access them from outside of these scripts. And so you will be forced to use the states dot change state in this case. Okay, input state. Then, because we don't necessarily need this to be public as well, you can just say you have to cast this as a test input state. So on start you can also do input state get component, or get component in children or in parent, depending how you set up your child objects. Keep that in mind. And let's search for test input state. Okay, and then on your test input state we can just do the same thing. String state, test string state, and then states dot change state, string state, and then string state get component test string state. So if you want to tweak this a little bit further and do this some more, we can just make this yeah, you can have your values on your current states and just do the rest as you want to. Obviously we can make this a little bit more dynamic and expand it a lot more than we have over here. Okay, so we have all of this. When pressing space you can see that we are changing. We forgot to assign the default state. You can just drag and drop this over here. Okay, and now we are in the string state. Now we are in the input state. Now we are in the string state. So yeah, as a component system and as a state manager that's based on a component system, then I think that's pretty much a crash course on how to make a component state manager system. Obviously we're going to see a lot more of this system, and I have an idea for a series that will be perfect for something like this, because it will have a lot of tweaking around. So we're going to see this later. So yeah, I think that's the main idea for this. I think this video is complete. We're going to see a lot more on our series, so you know, if you want to be informed about it, then subscribe, like, share the video with your friends, colleagues, family, or anyone else. And of course, if you like to see more stuff like this, consider supporting me on Patreon so we can keep making a lot more of these videos. I'll see you on the next one.